Hello. Okay. I'm making this really fast because I got to leave school at 5 and it's 4:52. So we're going to try to make it work. All right. Crap, where's my thing? All right. All right, cool. So I'm just going to scroll down to the math part and walk through a couple of these with you just real quick so that you kind of have an idea of where to go from here. So let me just make sure I got all this stuff. All right, so number 12, the volume of the gas is 300. Let's make sure this is calibrated. All right, the volume of the gas is 300 when the pressure is 1. At the same temperature, what is the pressure at which the volume of the gas is 3 liters? So we have a volume and a pressure. We are trying to find the pressure, and we have a volume. It says that the temperature stays the same. Okay, so this is going to be Boyle's law. It's P1 times B1 equals P2 times B2 because temperatures aren't even involved. So it's P, B1, 2, 2. Okay. So you're going to just plug this in. Your pressure is at 1 atmosphere. So we're going to have 1 atmosphere times the volume is 300 milliliters. Volume does have to be in liters, so we're going to go ahead and move that over. When you go from milliliters to liters, you're just moving your decimal point 3 spots to the left. Okay. So instead of here, we're going to go whoop, whoop, whoop. So we're going to have 0.3 liters. Set equal to pressure 2, because that's what we're trying to find, times 3 liters. Okay. And then you just have to solve for that. Okay. So you're going to end up having this times this, and then you'll have this times this. So you're going to end up having all of this divided by 3 because you're going to isolate P2. So we're going to have 1 times 0.3, okay, divided by 3 gives you 0.1. So your second pressure is going to be 0.1 atmospheres. And that's it. So let's do another one. Let's go down to one that's not going to be Boyle's law. So let's erase this. Okay. Let's see. Volume, we're not changing pressure, so this is just pressure and temperature. Yeah, okay. So this one's going to be Charles' law. I'm going to do number 14. It's up there. I'm going to do number 14. So if the volume of gas is 7.5 liters and the temperature is 4 degrees Celsius, if the temperature increases to 12 degrees, we're not changing pressure. Okay, so that's the one thing that's left out. What is the new volume? So since volume is going to stay, since pressure is going to stay constant, we're going to use Charles' law. That's volume and temperature. So we're going to have, So we're going to have volume 1 over temperature 1. So equal to volume 2 over temperature 2. Hi. Yeah. Hold on just a second. Let me. Okay. Sorry. Somebody walked in here. All right. So you're going to have your volume 1 over your temperature 1 set equal to your volume 2 over your temperature 2. So we're just going to plug this stuff in. So your temperature has to be in Kelvin. So we're going to go ahead and just work with it from Kelvin. So let me just move over to this side so you can see it a little better. Okay, so volume 1 is already in liters, so it's going to be 7.5. Okay, I'm going to put that over the temperature in Kelvin. To convert it into Kelvin, you just have to add 273. Okay, so we're going to have 4 plus 273. So we're going to have 277 on bottom, set equal to, those are parentheses, not ones. We want the second volume. We don't know what that is, so we're solving for V2 over 12 degrees Celsius. So we have to add 273. So what is that, 285? Okay, so now you're going to solve for that. So you can cross multiply and divide. So you're going to end up with B2 is going to equal 2.72 liters. 2.72 liters. Okay, so if I'm going too fast, you can just like pause it, rewind, look at that. But that's Charles' law. Okay, so we did Boyle's law, and that's Charles' law. We're going to do Gay-Lussac's law, combined gas law, ideal gas law. That's it. Okay, so I'm going to erase this. I'm going to move on. World's fastest lesson. Sorry, I wish I wasn't running so late today. Let's see. So let's do new 16. I think is Gay-Lussac. Yeah, it is. All right, so Gay-Lussac's law, we're going to do 16. So Gay-Lussac's law is looking at pressure and temperature. We're assuming that the volume was not intentionally changed, is the kind of the idea. So it says volume has not changed, so that's how you know it's going to be Gay-Lussac's law, because volume is consistent, it's not changing. So we have negative 22 degrees Celsius. The air pressure is 1.5 atmospheres. Volume's not changing. What is the pressure after the tire has been warmed up to 12 degrees? So Gay-Lussac's law is going to be pressure 1. Oh my gosh, what is going on? Okay. Pressure 1 over temperature 1 equals pressure 2 over temperature 2. Okay. So pressure 1 was 1.5 atmospheres over your temperature. Let's see. It's going to be 251. It's got kind of uncalibrated. All right, so I have 1.5 atmospheres over 251 Kelvin. Set equal to pressure 2, we don't know, and temperature 2. So temperature 2 warmed up 12 degrees, so 285. Okay, so you're going to cross multiply and divide those. Let me see. Okay, looks like pressure 2 is equal to 1.2 atmospheres. Okay, and you know it's atmospheres because where'd my thing go? It's already atmospheres up here. So hopefully that wasn't too fast, but there it is. All right, let's do one combined gas law and then one ideal gas. Boom. All right. Let's go down to, let's see, we can do 18. All right, so 18 is going to be the ideal gas law, not the ideal gas law, scratch that. 18 is going to be the combined gas law because we're still talking about a before and after situation. That's how you know when you're going to use Boyle's law, Charles' law, Gay-Lussac's law, or the combined gas law, is if you have like a before and after scenario. So this is telling you that like before, in the first scenario, it had these properties. Afterwards, we change these things. What's the missing variable? Okay, so that's going to be those 4 things. Ideal gas law is going to be used only when you're looking at like a situation that's currently happening. And I'll show you the difference whenever we get to that. So let's do 18. All right, so combined gas law is going to be exactly what it sounds like. Okay, so you're going to, my goodness. All right. You're going to have P1 times V1 over T1 equal to P2 times V2 over T2. Okay, so we're going to just start plugging this stuff in. For this, we already have our pressure in atmospheres. The volume's already in liters, and we just need to convert our temperatures to Celsius. Okay, so we're going to have 0.5 times 120 over, where are we at? We're at 15 degrees Celsius, so we're at 285 Kelvin. No, that's wrong. 288. I'm just going to change that bad boy. That's an 8. So now we're going to have pressure 2. Let's see. Pressure 2 was 0.75 atmospheres times volume. We don't know. We're going to find that. And then 10 degrees Celsius. So we're at 83. Okay, so now you just need to solve this side and then multiply 283 on both sides to get that out, and then isolate V2. So you'll divide 0.75 from both sides at that point. So if you put this on your calculator, you're going to end up with 848.1 Kelvin. Okay. All right. That's the combined gas law, right? So again, it's situational. So like this is like a before and after kind of thing. So Boyle's law is that way, Charles' law, Gay-Lussac's law, and the combined gas law. Okay, so those four are going to be like a before and after situation kind of deal. Okay, so like something was here, now it's here, what happened? So now I'm going to go ahead and erase this real quick. And we'll do an ideal gas law real quick here, and then we can be done. What time is it? Oh my gosh, it's 5:06. I gotta go. All right, so let's scroll. Let's do this. All right, let's find one. We can do. Let's do 21 because 21 is more difficult than number 20. So let's go ahead and just scroll this down here a little bit. So the thing about number 21 that's more difficult is what you're solving for. So this one's asking you the molar mass of the gas. This is just like number 3 on the ideal gas law example video that I did. And it's also just like number 3 on the practice sheet for ideal gas law. So this one, we're solving for N, right? Because N is moles, and from moles, we know we can find the molar mass. So we have to solve N into the best way that we can to find what we're looking for, okay? So what we're going to do, put this in here. Okay, so we have a mass of gas that's collected. We're trying to figure out like what the molar mass of that is. You could use this also to identify an unknown gas. Okay, so if it's something like this, you're finding the molar mass, you can use this to find the unknown gas by looking up its mass on the periodic table. So anyway, let's kind of push this all out. So we have temperature is 15 degrees Celsius. We're going to convert that into Kelvin. So that, what is that, 288 Kelvin. Pressure is 99 kilopascals. Volume is 200 milliliters. So we do need to convert that into liters. So we're going to have 0.2 liters. R is, so, all right, up here, gosh, I don't even know. Can you see that? Is it over here? So you have 2 values for R. Okay, it has to do with what unit the pressure is in. So if my pressure unit is in, focus on me. If my pressure unit is in atmospheres, I'm going to use 0.8205 in place of R because that's the universal gas constant. If my pressure unit is in kilopascals, it's going to be 8.31. Okay, so it's always one of these 2 things, and that comes from the unit we used for pressure. So back on here. Okay, since pressure in this problem is in kilopascal, R is going to be 8.31. That's just a constant. So every time it's in kilopascal, that's what you're going to use. Now N is what we're trying to find. So what we want to do is, because we have this mass that we're starting with, we need to convert this mass into moles to be able to solve for it. And obviously we don't know what that mass is going to be, right? Like we don't know what the molar mass of that is because we don't know what we're talking about. Like it's a molar mass of an unknown gas. So what we're going to do with that is we're going to have N, right? We know N is equal to moles. So we're going to use this 0.5 of whatever it is, that's grams. We're going to convert that into moles just like we'd convert anything else into moles. Except we don't know what the molar mass is. That's what we're solving for. We know the molar mass is always equal to 1 mole, right? So if I make this smaller, easier to work with, we're going to have 0.5 over x for N. Okay, so this is N. That's what we're going to put into the equation for N. If I get a different color here, we're just going to start plugging this all in, and then we'll solve for it. Okay, so we have PV equals nRT. PV equals nRT. Okay, that's your ideal gas law. So we're going to plug it in. So we've got 99, volume is 0.2 equals 0.5 over x times 8.31 times 288. Okay, now you're just going to solve for x. So you're going to isolate this part. Okay, so you're going to multiply this, you're going to multiply these, you're going to divide whatever that is from both sides. Then you're going to end up with something equals 0.5 over x, and then you can solve for x. So in the end here, x is going to equal 60.4 grams. Okay, and then at that point, you could, in theory, like look on your periodic table, find it on there, and say, oh, it's copper or whatever. So that is the ideal gas law. I know that was really fast and like ridiculous. So hopefully, I have colors on my face. Okay, so hopefully that was helpful. If it's not, please let me know. But you'll need this stuff. You'll want these numbers. The key for the study guide is on Canvas. So if you get on Canvas, that's on there. You can kind of like check your math work on all these. So please let me know if you need any more help. I'm going to be really busy this weekend, but I'll try to be checking my messages periodically. So hope that helps. Have a great weekend.